Can you please raise your hands if you get this? If you don't, can you ask me specific questions on what you did not understand about this? Right. 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 I'll come to that. Okay, let's just finish this slide and I'll answer your question on that. Okay. So the model is our approximation of the relation between x and y. For example, I can assume that x is related to y via the sigmoid function. And just as you had those mx plus c, I have introduced these parameters w here. And now my job is to learn these parameters w. Or I could have said that y is equal to w transpose x. What is this similar to? Equation of a plane, right? So y is equal to mx is the equation of a line. If it's in high dimensions, if I say y is equal to w transpose x, it's going to be the equation of a plane. Okay? And also you could have a quadratic equation, right? So this is of the form ax square, right? Where you have the w as the parameter, right? So this is what you typically do in machine learning. What you say is that I'll assume that the input is related to output via some function, and this function has some parameters. And now my job is to learn the parameters of this function using the data which I have been given. Is that okay? Fine. Now, any kind of learning, what is it driven by? So suppose you're learning trigonometry in school, right, in say 10th standard. What is the objective there? Suppose you're reading the chapter on trigonometry. What's the objective there? What is your learning driven by? What do you want to achieve at the end of it? What should you be able to do? Good. So at the end of the chapter, you'll have some exercises. If you have learned well, what would your error be on the exercises? 0, right? That's what your objective is. So learning, you'll keep reading the chapter again and again till you score a perfect score on the exercises or some other test or homework or something like that. So you always have this some objective which drives your training. Is that fine? Okay. So now in this case, can you tell me what your objective should be? And let's first consider the simple case because he had a question on the binary case. So I'll just take the simpler case where you're trying to predict the amount of oil that you can mine from a certain location. Okay. And now suppose I come by and I tell you that, okay, see, this function is actually related by y is equal to w transpose x. And here I give you the values of w. Go check them and they're going to turn out to be correct. What are you going to do? How will you verify whether the w's which I've given you are correct or not? You have given some training data x, y to you. What will you do? Give me the procedure. You will take an x from your training data. You will then compute w transpose x and compute y. Then what will you do? You will compute the difference. And then you will tell me this is how wrong you are. How wrong am I? Y minus computed y. Right? So true y minus computed y. And let's call them y and y hat. Right? Y hat is the computed y and y is the true hat. Okay? And you'll ask me to keep refining my weights till y minus y hat goes to 0 for what? All the training samples that I have. Does that make sense? Okay. So now here's where you need to understand the trigonometry analogy, right? So what you're trying to do is, you're trying to minimize the error on the which data? Training data. So that's the same as while you're reading the chapter, within the chapter there were some exercises or some blocks in which some formula were written. And you need to make sure that while you have finished reading the chapter, you at least get these correctly, because this is what your training data is. While training, you are being taught that sin square theta plus cos square theta is equal to 1. So you better answer that correctly. Okay? And then later on, in your test, you're given some new problems. Maybe there you're given what is 1 plus tan square theta, and you have not read that yet in your training data. But your learning should be such that even you perform well on the test data also. Right? That's what your training is. But while training, your objective is, because the training data is all that you're given, I have not given you a new location where I'm trying to find oil, so you don't know what's going to happen there. You can only predict that. And I cannot give you any feedback because I don't know the answer. Only after you give me an answer, I'll decide whether to invest there. And once I start digging up a few years down the line, I'll have the answer. Right? Does that make sense? All you have is the training data, and you can minimize the error only on the training data. That's what you're going to do. Is that fine? Okay. So now, can you give me a formula? And I'll start saying, I'll give you the first part of the formula. What you're trying to do is, you're trying to learn the parameters W such that you minimize summation. I want you to complete this. Summation I is equal to 1 to, I is equal to 1 to N, Y minus, yi minus y hat I, y whole square? No, absolute. So if you square it, you will not run into this problem that in some cases I made a error of plus 5. In some other cases I made an error of minus 5. So this will cancel it out and I'll think that I've made a 0 error, right? But if you square it, everything will be positive. That's why you take the square. What's the other reason why you take the square? It's dash. That's also correct. But in terms of mathematical stuff, someone said the answer. It's differentiable, right? So if you take the square, that makes a lot of things easier for you. Okay. So now this is the typical setup. You have these 5 parameters, or rather 5 elements. We have the data, model, parameters, learning algorithm, and objective function, right? So for the movie example, let's look at this. What's the data? The x's are the movies. So you're given all this information about the movies. And the yi is whether you like or dislike the movie. What's the model? What's the model that you chose? Y is equal to sigmoid of x, right? You can just say it in short as logistic of x. So this is the model that you chose. What did you introduce while making this model? Parameters, right? Why did not I say that y is equal to 1 over 1 plus e raised to minus 3x? That's also a fine model. Why did not I say that? There are no weights, there are no parameters in that function. So what will I learn from the data? Right? I just said that y is equal to 1 plus e raised to minus 3 raised to x. Sorry, e raised to minus 3x. Right? So there's nothing to learn there. Okay, only when I introduce parameters, then I can look at the training data and try to learn these parameters. Okay, so that's the model part. The parameter is w in this case. What's the objective function? That's where I'll come back to his question. So his question was that the sigmoid is going to predict a value between 0 to 1. But all my y's were only 0 and 1. So now what is the error function that I'll choose? Can I still choose the squared error function? Yes, right? Because so suppose the sigmoid function predicts 0.2 when it was supposed to predict a 0, you'll get an error of 0 minus 0.2 the whole square. Right? So even in that case, what's the best solution? The best solution is the model should predict a 0 when the output was 0 and it should predict a 1 when the output was 1. Only then you'll have a 0 error. Does that make sense? Everyone fine with that? Okay. Right? So our learning algorithm is going to be gradient descent and the objective function is going to be the squared error loss. Is that fine? Okay, so now let's understand which parts we are clear with and which is the part which remains. Which is the part which remains? Which is the thing that I need to tell you about now? I've told you the data, I've told you the model, I've told you the parameters, I've even told you the loss function. What is it that I've not told you? Learning algorithm. How to learn these parameters. Okay, that's the one which we need to learn. And what we are going to do is, we are going to learn something known as gradient descent, which is used for learning these parameters. Okay, so let's start with that. So we have the model, we have the parameters, we have the data, and we have the objective function. Now what we need is this learning algorithm. Okay, and sigma stands for the sigmoid function. So for ease of explanation, what I'm going to do is, instead of having these n inputs, right? So I had x1 to xn. Actually, I've made a slight error here. So this n is actually m. So this is the number of features that I have, right? And not the number of data points that I have. So is that clear? Is that okay with everyone? Okay. So now what I'm going to do is, instead of basing my decision on these various factors, I'm going to say that I have only one factor, which is x. Okay, I don't have x1 to xm. I just have the single x. Okay, and I have this another thing, which is the bias. What was the bias? It tells me my prior, right? How likely I'm going to take this decision without even seeing the input. Right? That's roughly what the bias is. So instead of having this x1 to xm and the bias, I just have x and the bias. Is that clear? The way I've simplified this equation. And instead of having this w1 x1 plus w2 x2 plus w m xn all the way up to mn xm, I just have wx plus p, one input and one bias. So how many parameters do I have here? 2. How many parameters did I have earlier? M plus 1, right? M factors and then m features and one bias. Now I just have 2 features, okay? So it's just for ease of illustration, I'll just work with 2 features. And the same algorithm you can extend to m features also, okay? Fine. And to be consistent with the literature, instead of W0, I'm going to call it as B, because B stands for bias, and that's what everyone uses. And lastly, instead of predicting a yes-no decision, I'm taking the problem where I'm given the critics rating, and I want to predict I'm given the IMDb rating of a movie, and I want to predict the critics rating from that, right? So I've been given an IMDb rating, assume it's between 0 to 1, and I want to predict what's the critics rating going to be. Is that fine? Okay? So that's what my setup is. And in this setup, what do I need to tell you? How to learn? What do I need to learn? W and B. How do I learn W and B? That's what I need to tell you. Okay? Fine. So this is the input that I've given you. I've given you some capital N training examples. And the training objective is also fine. Yi is the true output, and f of xi is the predicted output. And what do I want? I want to minimize the difference between them for all the n training examples I have given. So this is an optimization problem where the parameters of the objective of the optimization problem are? What are the parameters of the optimization problem? I'm trying to minimize this with respect to what? Weight and bias, right? So always remember that. So when I say, suppose I give you an optimization problem that minimize x square, what do you have to give me in return? No, minimize x square. Just forget this. Suppose I say minimize x square. You have to give me a value of x for which x square takes the minimum value, right? So that optimization problem is with respect to x. Similarly, this optimization problem is with respect to w comma b, because I've given you a quantity that you need to minimize, and you have to give me a w comma b which will minimize that quantity. Does that make sense? Okay. So this optimization problem is with respect to w comma b. Everyone fine with that? Okay, fine. So now, what does it actually mean to train the network? So let me ask you this question, right? Suppose I give you the points. I'm giving you only 2 data points for training, suppose, okay? And these are the 2 points, x comma y is 0.5 comma 0.2 and 2.5 comma 0.9. These are the 2 red points that you see on the graph at the bottom. Now suppose I tell you that the network has been trained. What does that mean? At the end of training, we want to find w star comma b star such that. Now, what does that mean? Can you explain in plain English? Okay, so now that means, so let me just make it more elaborate, right? So learning the function f, the function that you have chosen is the sigmoid function. That function has the parameters w comma b, right? And you tell me that I have done the training. I've learned these parameters. At the end of training, if I give you the value of x as 2.5, what would you expect? What would you expect y to be? 0.9. It should be as close to 0.9 as possible. Suppose I give you the value 0.5, 0.2, right? Is that fine? So what you want is, at the end of training, if you plug in your training data itself, which was the x's given to you, you should get the y's which are the same as what you had in the training data. Does that make sense? And that's another way of saying that you want to minimize the distance between the true y and the predicted y. Is that fine? Now in terms of the, I wouldn't call it geometric interpretation, but in terms of the geometry or in terms of the plot, we're trying to learn a sigmoid function. At the end of training, if you learn these weights w comma b, and if I plot that sigmoid function, what do I expect? What do I expect with respect to these two red points that you see on the figure? I'll ask you a slight variation of this question, and all of you will answer. Okay? Suppose your quest was to learn y is equal to mx plus c. And I had given you 2 points. And you learned m and c. At the end of that, if you plot that line, what do you expect with respect to those 2 points? Those 2 points will lie on the line. Same question with respect to sigmoid. What do you expect? Those 2 points should lie on that sigmoid curve. Does that make sense? The same analogy? Okay, fine. So this is what you hope. That at the end, when you have learned the weights and the bias, if you draw the sigmoid function, these 2 points should lie on that sigmoid function. Does that make sense? Okay, fine. So let us see all of this in much more detail. So first what I'm going to do is, instead of giving you an algorithm, I'm just going to do some random guessing. What I'm saying is that I'll try to find these weights and biases manually. So I'll start. Okay, let me see. I'll start with a random guess. W is equal to 0.5 and B is equal to 0. And I plotted the sigmoid function. Okay? Is this good or bad? Good or bad? Bad. Okay. How bad is it? This much and this much. How bad is it? Can you give an answer for that? A definite quantitative answer for that. Good. You want to calculate the error. We already have seen the formula for the error. What will you do? Just substitute these values, right? So what you will do is, okay, this is, so if you substitute the value 2.5, you will get a point on this red sigmoid, right? That's the value of y according to this sigmoid function. You'll find its difference from the actual y, which is 0.9, square it, and that you'll do the same thing for the second point also. And when you add these quantities, what will you get? You'll get the loss function, right? So let's see. So what you'll do is exactly what I said. You will plug in, what's the value of capital N here? What's the value of capital N here? 2. Right? For both those points, you will substitute this, y1 and f of x1. You'll compute the squared error difference and 0.073. So that's how bad this is. If it was good, what would this value be? 0, right? So that's, now you can relate how bad this is. So when I ask you a question, how bad it is, and if I give you multiple values, you'll be able to tell me whether one is bad than the other, worse than the other, right? Okay, fine. So I started with this guesswork, and I saw that, okay, I make an error, and I could actually exactly compute the error also, and I found that this is the error. So I said, this is bad, let me try something else. Okay, so I substituted some, I guessed some other values for w comma b. I said w equal to -1 and b is equal to 0. Is this bad or good? That's the correct answer, even though that was not the option. It's worse than the first one, right? Why? Because you can actually compute the loss, and the loss is greater than what you had computed earlier. Is that okay? Right? So now what will I do? I'll continue guessing. So now I'll do some, and this is exactly how I've plotted this graph, right? I'm not just cooking up the story. I saw that, okay, W negative is not working for me. W positive was still okay. Let me try to increase W a bit further. Okay? And maybe make the bias a bit negative because I have not tried negative value rate. And I tried that, and I ended up with something better. Right? And I can see from the loss function this is better. Now what would you do next? Maybe increase the W a bit more, and maybe make B a bit more negative. Right? And this is what I got. And I continued this way. And by random guessing, but a bit of educated guessing, right? Not completely random guessing. I was seeing what happens when I substitute different values of W and B. I was able to arrive at the answer. Right? So we are done, right? We have a perfect algorithm for computing the weights of W comma B. All of us can go home. What's the problem? Sorry? What if there's a third point? Or what if there's a third dash? Parameter. What if there's a fourth dash? Parameter. What if there are a million dashes? You'll get lost, right? You cannot do it. You can do it for the toy example, but this guesswork cannot continue if you have a really high dimensional space. Does that make sense? Right? So let us look at something better than our guesswork algorithm. That's what we want to do, but before that, we'll just end up with this guesswork algorithm. So since we had only 2 points, right? So I just have the w axis and the b axis. What I can do is I can take all possible values for w and b. Okay. I'll take all possible values from -infinity to infinity, which I can obviously not plot on this slide. So what I'll do is I'll take all possible values from some -6 to +6 for w comma b. I'll compute the loss function for each of these. How will I do that? Just as I did earlier. I'll compute y as a function, the sigmoid function, with w and b as the chosen values. I know the original values. I can compute the loss and I'll plot it. And this is what I get. So what you see here is something like a flying carpet, and it's actually color coded. Darker the shade of red, the worse it is. That means the loss is high. Darker the shade of blue, the better it is. The loss is low. And at the darkest shade of blue, what's the loss? 0. Okay, fine. So this is actually the error surface. And what I was doing is I wanted to find the best possible point on this error surface. And then a 2-dimensional case, all of this is very easy. I can actually look at this and physically find out where is the lowest error possible, right? But here again, remember the first thing which I started with is I cannot do it for -infinity to infinity. I could do it only for some values between -6 to +6, right? And then find the answer. But what if the optimal answer lies beyond -6 to +6, right? So even in the simple 2-dimensional case, you cannot do it. If you have many, many more points, I had only 2 points here. If I had a million data points, I can't compute the loss of all of them and then plot it like this, right? And if I have many, many more parameters, I just cannot do it, right? So this random guesswork, while gives us some intuition of what we are trying to do, it's not feasible in practice, okay? And let's look at the geometric interpretation of what we were actually trying to do in the random guesswork algorithm. What we are doing is we started with a random w comma b. So you see the dark black point at the bottom of this plot on this side, right? And corresponding to that, you have the loss function at the top. Is that fine? So that was my first guess for w comma b. And then I came up with a different guess. What happened? What happened to my loss function? It actually increased, right? So you see that the second red dot is higher than the next red dot. And then I made a slightly better guess. What happened? It started decreasing. And then I continued and I started entering this dark blue value, right? So now what am I actually looking for? I'm looking for an algorithm which allows me to navigate this error surface efficiently without doing any brute force or guesswork. Right now what I'm doing is, you can either call it guesswork or you can even call it brute force. Right? I'm just trying to find all possible values, compute the loss, and select the one which is the smallest. But what I want is, I want a smarter way of navigating this error surface so that starting from anywhere, I can reach these favorable points, which are the dark blue points. Does everyone get that? How many of you get what we want to do? Okay. Fine. So that is what we want to do. We want a more principled way of traversing this error surface efficiently without resorting to brute force or guesswork. Okay, fine. So now let's just define some quantities more formally. This is just to get some notation in place. So this w comma b, which are 2 parameters, I'm going to put them in an array or a vector, right? And call that vector as theta. So theta is a vector which is 2-dimensional and it has the values w comma b. Does everyone fine with that? Okay. Now let's agree that to begin with, I have to start somewhere, right? I don't know what w comma b is. So I'll start with a random value for w comma b. I'll just start with some random value. And what I was doing in my guesswork is, I started at a random value and I was trying to move around and see which is the good direction in which I can go. Okay. So what I want actually is, starting from this random w comma b, I want to change it slightly so that I end up with new values for w comma b, and these new values, at these new values, what should the loss be? Less than where I had started from. Does everyone get that? And now from these new values, what am I going to do? Again, move to a new value such that my loss is less than the previous value. And iteratively, I'll ensure that wherever I had started from, my loss is continuously decreasing. Right now, my way of doing this was guessing. I want a more principled way. So if I give you a more principled way, what would happen at every step? In the guessing case, what happened at some steps? Loss actually increased. If I give you a principled way, what would you expect? Loss always decreases. It never increases. Right? That's what you would want. There should be no jumps and then, okay, I'll come back again. Is that fine? Okay. So I want to find these delta theta. And let's look at what it will look like. I have this vector theta. I'm going to add a vector delta theta to it. Okay? What does that addition look like? This, you'll get it by the parallelogram law. Okay? But now what I'm going to do is, so one way of looking at this is when you add theta or when you add delta theta to theta, your theta actually moves in the direction of delta theta. Fine? Okay. So now what I'm going to do is I'm going to be a bit more conservative. So instead of moving by delta theta, I'm going to move only by a small value in that direction. So remember, a vector has a direction as well as a magnitude. All I'm saying is the direction is fine, but I'll move only by a small magnitude in that direction. So instead of this theta nu which you currently see, what will your theta nu be? This new red vector that you see. Is that fine? Okay. So this is what my formula is. The new theta is equal to the old theta plus a small step in the direction of delta theta. Right? Does that make sense? Okay. So we are done. Anything missing here? Okay. Only one student thought of that. Yeah, so eta is that small number. Yeah, it will only be one eta throughout. It could be 0.001 or something like that. But I'm just calling it by eta. Yeah, so delta theta has a direction as well as a magnitude. So direction comes from delta theta. The magnitude, I'll scale it down by multiplying it by a very small quantity. So if you look at the figure, right, you had this delta theta, and then eta times delta theta was again in the same direction, but a very small magnitude. Right? So I'm going to scale down delta theta by that magnitude. Right? But my question is, are we done here or is there something missing here? What is delta theta? I did not tell you what delta theta is. I told you that take theta and from theta move by doing this equation theta plus delta theta. Right? But what is delta theta? How do you find delta theta? Right? So if I give you an answer for that, then are we done? If I give you an answer for delta theta, which assures that every step that you take, the loss is going to decrease from the previous step, then are we done? Is that fine? Okay, so that's what we want to find now. Okay, and actually the answer for this comes from something known as Taylor series. How many of you are familiar with Taylor series? Please raise your hands. Okay, now when I show you the Taylor series, all of you will raise your hands because it can't be that you have not seen this before.